Everyone is racing to pick the best model, fine-tune the best pipeline, and ship the most impressive demo. But the engineers quietly building systems that actually hold up over time? They're focused on something far less glamorous: judgment. Specifically, the judgment to know when automation is the wrong answer entirely. We've entered a phase where the default instinct for every engineering problem is to reach for an agent. And here's the dangerous part. The tooling is now mature enough that the answer is almost always technically yes. You can automate it, you can hook it up, you can ship it. That ease of execution is exactly what makes the question so misleading. Capability is no longer the filter. Wisdom has to be. Technical debt is something every engineer understands, shortcuts that slow you down later. But automation debt is a newer and arguably more dangerous phenomenon. When you chain together 8 agent skill invocations to handle a single workflow, you've created a system where a single failure requires forensic-level debugging just to find the origin point. Unlike code you can read, automation mazes are opaque by nature. They compound quietly until suddenly they don't work at all. Agents genuinely shine in a very specific profile of work. Tasks that happen at high volume, follow predictable patterns, and where an occasional failure is cheap to absorb and easy to correct. Think data formatting, routine classification, or repetitive document parsing. The problem is that this profile describes maybe 30% of real business workflows. The other 70% involves edge cases, contextual nuance, and consequences where failure is genuinely expensive. That's where teams are reaching for agents anyway. There's a seductive metric at play here: throughput. An agent completing a task 100 times a week looks incredible on a dashboard compared to a human doing it 10 times. But that comparison collapses the moment you examine quality in high-variance situations. A human who has handled a workflow for 6 months has built up an invisible layer of contextual understanding. They know the weird client, the seasonal exception, the edge case that breaks the pattern. An agent has none of that. It just processes faster into the wrong answer. The first wave of AI engineering problems was about capability. Can we make these systems work at all? The second wave, which we're entering now, is about restraint. It's the much harder question of identifying which pieces of human judgment in a workflow are genuinely load-bearing versus which are just friction that slows things down unnecessarily. Removing friction is valuable. Removing load-bearing judgment is how you build systems that fail in production in ways nobody predicted during the demo. The engineers earning the most respect in serious AI shops right now are the ones who slow down before the build phase and interrogate whether automation is actually the right call. This requires a very human set of skills: understanding failure modes, knowing what users actually need versus what they say they need, and having enough workflow intuition to spot where variance hides. These are not questions you can prompt your way out of. No model tells you where the load-bearing human judgment lives in your specific system. That's still your job. Most teams haven't yet developed the instinct to distinguish between automation that genuinely improves a system and automation that just looks impressive until it quietly causes serious damage. The organizations that build this judgment, that treat restraint as a first-class engineering discipline alongside capability, are the ones that will build systems people can actually rely on. Not just in the demo environment, but 6 months later when real edge cases arrive and real consequences follow.